Now we're going to go ahead and skip a couple sections and we're going to jump to number patterns, which is section 3.9. And this will be our last section of this chapter. We're going to divide this into three parts. There's three keys dealing with number patterns. The first one is each number in a sequence is called a term. Each term has a position, and this is very important. We're going to identify the positions or the terms, identify the pattern, and then find the next two terms in the sequence. So let's find the pattern here. 2 plus 7 equals 9. 9 plus 7 equals 16. 16 plus 7 is 23. Okay, now I'm taking that 23 plus 7 equals 30. So 9, 16, 23, 30. Okay, what's the pattern here? I'm adding 7 to every one of these. Now this is a little more complicated than 2, 4, 6, 8 or 5, 10, 15, 20. This we need to actually figure out, and we may succeed, we may fail in figuring out, is it times 2? No, 9 times 2 is not 16. Is it 9 plus 9? Is it 9 plus 8? No. Is it 9 plus 2? No. Is it 9 plus 3? No. Is it 9 plus 7? Yes. Okay, let's see if 16 plus 7 is 23. It is. So the pattern is it's plus 7. So we will have to experiment and try different things. Some things will be correct, some things won't be. So we found the pattern, and the pattern is plus 7. So we're going to do 37, or 30 plus 7 equals 37, and then we're going to do 37 plus 7 is 44. Okay? So now let's move on to another practice example. And the pattern here is already given to us fully, except there are some missing pieces, not at the end, but throughout the middle. So we have 2, 4, 8. Oh, it's not 2, 4, 6, 8. It's 2, 4, 8. So how am I going to get this? I can do 2 plus 2 is 4. That's good. But 4 plus 2, no. That would be 6. We can do 2 times 2 is 4. Okay. Is 4 times 2 8? Yes. So it's times 2. So if 2 times 2 is 4 and 4 times 2 is 8, 8 times 2 is 16, then we can go ahead and focus on 16 times 2 is 32. 64 times 2 is going to be 128. Now let's do practice number 3. We have a pattern 1, 2, 4, 8, and 16. Okay, 1 times 2 is 2. Okay. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That makes sense. There's a good pattern there. I can also do 1 plus 1 is 2. 2 plus 1, no, that doesn't work. Okay, 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3, no, that doesn't work. So probably times 2 would be a good example. Here we have it's evens plus 2, 4, 8, or we can do times 2. Okay, that gives us 32 and 64. Now let's go ahead and do the practice. Practice number 4. We have 7, 18, 29, 40, and 51. Now, when I break this down, I'm going to have to try many different things. Maybe 7 times 2. No, that's not 18. I can do something that could simplify some things. I can take 18 and subtract that from 7 and find out 18 minus 7 is 11. Let's see if 29 minus 11. It is. So 11 is my pattern, plus 11. So 51 plus 11 would be 62. And then 62 plus 11 is 73. Now, if I get that 51 plus number, okay, wrong, that's going to also impact that second number. So I do need to make sure and check that the other ones work. Let's go ahead and look at part 2. Now, not only am I focusing on identifying the pattern and the term, but I'm going to focus on the terms in a sequence and identifying that they can be figured out or identified by position that they hold. So this is important, okay? Follow along here, okay? If the question is find the 2,400th term, there's no way I can do that off the top of my head and go 2, 4, 6, 8, 10 and write that out up until my 2,400th number. Okay, I can't do that. The focus here is that it's communicating by position. Find the 2,400th term, okay, the 2,400th position. So the focus here is we are multiplying by the position held. We're not doing 2 plus 2 or 0 plus 2. Yes, we can look at that and say, okay, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. But the question here is we want to identify the term based on the position. So each term is twice its position. So 2 is in the first position. It's the first number given. So 2 times 1 is 2. 4 is the second position. So 2 times 2 is 4. 6 is the third position. So 2 times 3 is 6. 8 is the fourth position. So 2 times 4 is 8. So if we're looking at 2,400th position, the 2,400th term, we'll multiply that by 2, and that will give us 4,800. So this specifically, you will be told if you're focusing by position, okay? By position. So this is different than we're just adding plus 2 or times 2. Okay, let's take a look at this one. Find the 50th term in the given sequence. So the focus is the 50th term. Okay, we're focusing on position. And what we're going to be doing here is we're going to take this number. This is a little more complicated. We're going to take this number and we're going to break it apart into it's the first position, and we're going to multiply 3 and then add 1. So 3 times 1 plus 1 equals 4. 3 times the second position is 2 plus 1 is 7. 3 times the third position is 9 plus 1. 3, and that's going to give us 10. 3 times 4 is 12 plus 1 is 12. That is going to give us our answer here. So if we just do the same thing we did in the previous one, we would not be getting the same pattern. Okay, so we may have to do a multiplication and then an addition. Okay, so this is something you may see next year, but we're going to try it out this year. So 3 times the 50th term, so 3 times 50 plus 1, that would give us 150, and then plus 1 is 151. Let's take a look at the next practice. Let's identify the pattern. 9 times the first is 9. 9 times the second position is 18. 9 times the third position is 23. 9 times the fourth position is 36. So I found the pattern. I'm multiplying by each position. So that's very basic. Now I'm not having to add 1 or 2 to that multiplication, so that's easy. So I can take 467 and multiply that by 9. Okay. Let's take a look at the next practice. Identify the pattern of 1, 4, 9, 16, and 25. What I'm doing here, okay, it's the first position. 1, what can I do? 1 times 0 would be 0. No. 1 times 1, maybe. But if we look at the second position, 2 times 1 would be 2, so it wouldn't be 4. So what do I have to do here? I have to experiment with some things. Is it 1 times 1 plus 3? Well, then the first one wouldn't be correct. But what I find here is if we try some different things, one of the options that I can do is square it. So 1 times 1 is going to be 1. 2 squared, or 2 times 2 is 4. Then we have the third position. 3 squared, or 3 times 3, would be 9. Here we have the fourth position. 4 squared, or 4 times 4 is 16. 5 position. 5 squared, 5 times 5 is 25. Okay, that's great. Let's find the next, ones. And this is asking us specifically for the 40th term. So I want 40 times 40, or 40 squared. And that's going to give me, 1,600. And remember, one way I can do that is 4 times 4 is 16, and then I have 2 zeros. So I'm using what we learned in the past. So we're starting off real easy with finding a basic pattern. Then we move into something a little more difficult, dealing with positions. Now we're going to get into something where it seems like there is no sequence or pattern at all, but there really is one. So this is even more confusing. So you really have to think outside the box on this one and really think and stretch yourself. Okay, let's identify the pattern. Now we have to try some things. You have to try. It's okay to be wrong, but you can't give up. So you're going to try to find the patterns. Okay, is it 6 times 2? No, because 6 times 2 is an 8. Is it, we can do 8 minus 6 is 2. So is it 2 plus 6 equals 8? Okay, that makes sense. Is it 8 plus 2 is 11? Okay, so what am I finding here? What do I have to figure out? Am I going to add to each position? Maybe I'm combining positions. So let's see what we're doing. 6 plus 2 is 8. 8 plus 3 is 11. 11 plus 4 is 15. 15 plus 5 is 20. 20 plus 6. So each one that I'm adding to, I'm increasing. 2 plus 3 plus 4 plus 5 plus 6 plus 7. So 33 plus 8. And then 41 plus 9. That's my pattern. Now let's find the next two terms. Is it 7 plus 1 is 8? Okay. 8 plus 1 is 10? No. 8 plus 2? Ooh. Okay. 10 plus 3? 3 plus 4? Oh, very similar to what we just had. We're doing a plus 1, 2, 3, 4, 5. So 17 plus 5 is 22. 22 plus 6 is 28. So it may not seem that there's a pattern there, but there is hidden within the numbers. Let's try this one. 3, 5, 9, 15, 23, and 33. What am I doing? I'm adding 2 to each one of these. Okay, I'm adding 2, then 4, then 6, then 8, then 10, then 12, then 14.